Okay, now we will talk about the decomposition of a time series. Go to the seventh spreadsheet. A time series data contains one or more components of demands. The components of demands usually include the level or base component, base demand, or trend, or seasonal effect, or cyclical effect, or random variation. So decomposition of a time series is to identify and separate the time series data into components of demands. It's relatively easy to identify the trend. We have an upward trend or downward trend line like this, and we can find the seasonality in the time series data, usually repetitive pattern over a 1 year period of time. But sometimes demand contains both seasonal and trend effects at the same time. Suppose this demand data contains both seasonal and trend effect. So let's look at how to decompose using the least square linear regression. We start by usually calculating seasonal index or seasonal factor. Then using that data that has been deseasonalized, we estimate the trend line using the linear regression. Then we can forecast trend line and adjusting the seasonal factor into that trend line. So here is the process. Number one, decompose the time series into each component. Define the seasonal components, then deseasonalize the demands, then find the trend components, and then forecast the trend future value of each component. So project the trend component into the future, then multiply trend component by seasonal indexes. So when you look at the former steps, there are 5 steps. Firstly, you can determine the seasonal factor or index and deseasonalize the original data. Then develop a least square regression line for the deseasonalized data and project the regression line through the period to be forecast. This is a project, your trend line. Finally, create the final forecast by adjusting the regression line by the seasonal factor. Okay, so to find the seasonal factor, you need to find out average of the same quarter of each year. So just average of quarter one. So quarter one in the second year and quarter one in the third year. Just click. Do the same average of second quarter in the first year, second quarter in the first year, second year, and the second quarter in the third year. That way you can just find out the average. And third quarter in the first year, third quarter in the second year, third quarter in the third year. Finally, average of fourth quarter in the first year, and then fourth quarter in the second year and the third year. Then seasonal factor, you have to using this average of same quarter of each year. It should be fixed. So we're adding the dollar sign, divide by average of this the demands. Again, this should be fixed. Okay. Then click. Do the same. Average of second quarter. That should be fixed. Divide by average of entire demands. Same thing. And then lastly, click divide by average of this whole demand. And then click. You see this seasonal factor is applied to the first year. And you want to apply the same seasonal factors into the second year and third year, right? So click and copy. Then you can paste special with the formulas, right? Same thing. Paste special with the formulas. Then this seasonal factor, same seasonal factors are applied in the second year and then third year, right? I want to highlight with different color here. Then you have to deseasonalize demands. Column 3 divided by column 5. So here, divide by column 5. That way, the actual demands divided by seasonal factor. And copy and paste. Then we can square up in time period. Okay? But this is not necessary at this point, but this is in the process. Final process is time switch the time variable, which is column 1, times column 6, which is the deseasonalized demands. Okay? This is the step 1 and step 2. We are done with the step 2 right now. Now let's develop the least square regression line for the decisionalized data. We are using this decisionalized data, and then what we have to do now is develop the least square, the regression equation. We have to know the intercept. So using the intercept function, the known y, we have to use not this actual demands, but decisionalized demands. This is one thing you have to be very careful. And then comma, and then known x is the time variable. Okay, slope is the same. Using the slope function, known y, use the decisionalized demands, comma, time variable t. That way you can develop the final decisionalized equation. Y equals, so intercept A is 554.99 plus slope 342.18 times t. So that t, when you forecast your time, trend line, you have to, insert this time period into this t. So step 4 is project a regression line through the period to be forecast. So using the y here from regression line, you have to use the intercept plus slope times time period p. Here 13. But we want to fix this cell while the period is changing, because we want to use the same number here. Click. Then using this formula, you can copy to period 16. That's the step 4. Then finally, create the final forecast by adjusting the regression line by the seasonal factor. So basically, you use this trend line multiplied by seasonal factor. By the way, seasonal factor should be copied from here. And when you copy and paste, I will use the say value, then see what happens. Be careful that you do not want to use this value as they are. You have to actually use this seasonal factor by, I think we can use the 2 decimal places. So 0.82, 1.10, 0.97, 1.112. That way you can find it more clear. You can use the seasonal factor without the round up by 2 decimal places. Then your number will be slightly different. So here, your regression line times seasonal factor. That's your final answer by adjusting your seasonal, the variation. So this is your final answer. Forecasting for period 13 is 41 to 0.75 and all the way. If you use the without the rounding up by these 2 decimal places, then your answer will be slightly different. So make sure that you can round up. Okay, that's it.